So in this class, we will go back to moment of inertia problem. So this is an important type of problem. The question is the cross section of a plain concrete culvert. So all of you may be knowing about culvert. A culvert is a structure which is built to drain the storm water or any other drainage water, something like that. So this is made of plain concrete, and you can see that this culvert is an opening like this. It is in the shape of a semicircle whose radius is 650 millimeters. All the dimensions are in millimeters, and the height of the culvert is 1000 mm. Width at the base of the culvert is 1000 plus 800, 1800 mm, and at the top it is 1000 mm. That means it is the shape of a trapezium. So this is an opening. So this is an opening through which water flows, and the road will be there on this. That means this is a 1 meter small pathway. You can say it's a pathway because culvert is a very small structure to convey dry water or rainwater. Now here he has asked the moment of inertia about the horizontal centroidal axis. That means you have to locate the centroid of this shaded area. Shaded area is the plain concrete portion, and the semicircular portion is a open area which is a cutout portion which is used to convey water through that. Now if you observe the diagram, it is symmetrical about y-axis. You can see if we take y-axis here, left half of y-axis and right half of y-axis, they are same. So the given section, the given culvert section is symmetrical about y-axis. So once it is symmetrical about y-axis, according to the property of centroid, the centroid lies on y-axis. So always centroid lies on the axis of symmetry, that is G, that is centroid lies on y-axis. So only we need to find y bar. There is no need to find x bar. Y bar is given by sigma ai by sigma ai. So this formula you know already. So first we locate the centroid of this culvert section. For that we have to divide this culvert section into so many simple sections. So let me divide it. So this is the culvert section which is symmetrical about the axis. I will take the bottommost axis as the x-axis so that this becomes the origin. Now it is of semicircular shape like this, whose radius is given as 650 mm, and this height is given 1000 mm, and this is 1000 mm top width, and additional width, this is 400 mm, this is also 400 mm. So it's a trapezium. Now you can just see that the shaded area is obtained by splitting this entire section into so many simple sections. Let me divide this into simple sections. Here you can observe that there are two triangles. If you draw an ordinate here, so this is triangle 1, and another ordinate here, so the another triangle will be get. You are going to get a rectangle or a square here. This is 1000, and this is of course this is also 1000. So therefore it becomes a square. So 2 is a square, 1 is a triangle, 3 is a triangle, 4 is a semicircle. So if I take these areas as A1, A2, A3, A4, your total area becomes A1 plus A2 plus A3 minus A4. So sigma AI will be obtained from that like that. So sigma AI is equal to A1 plus A2 plus A3 minus A4. Let us find out locate the centroid of this composite section. So by our usual method, I will take in the form of a table. So serial number, figure, then area AI in millimeter square. You have 4 simple sections there. Then you have y term, distance of the centroid of each simple section from the reference x-axis. Then ai into yi, which is given by perimeter cube. Now here The first figure is, I will take it as a triangle. First one is a triangle. Area of the triangle, if you see here, so height is 1000 mm, width is width of the base is 400. So half into 400 into 1000. Half into 400 into 1000. Afterwards we will simplify this. Then yi. So yi is the distance of the centroid of this triangle. It will be somewhere here. G1 I can take from the x-axis. So the x-axis is this, bottommost edge of the x-axis. So this distance will be 1/3 of the height. So 1/3 into 1000. Since it is measured above x-axis, yi is positive. So 1/3 of 1000. So that is the value of yi for the triangle. Now second one is a square. You can see this is a square, 1000 by 1000. So 2 is a square whose area is 1000 into 1000 or 1000 square, which is nothing but 10 to the power of 6. So that is the second one. Now let us write the value of yi. Yi for this, that means I have to take the centroid of this square, which lies at a distance of 500, because suppose it is 1000 divided by 500 means it will come somewhere here only. So this is d2. So distance of d2 from x-axis is 500. So that is yi value 1000 divided by 2. Then the third one is the once again triangle. Third one is once again triangle whose area is the same as the first triangle area. Half into 400 into 1000. Half into 400 into 1000. Then the distance of the centroid of this, once again it is d3 by day. It will be distance is 1/3 of 1000. That is also same, 1/3 of 1000. So it is 333.33. Here also it is 333.33. Next, coming to the fourth one, is a semicircle. So we have to deduct the area of the semicircle. So since we have to deduct, I will take minus sign. It's a cutout portion. It is the shape of a semicircle. So pi r square by 2. So where r is 650, we have given pi into 650 square by 2. Negative sign because it's a cutout portion. And the distance of the centroid of this semicircle from the x-axis G4 is 4r by 3 pi. That we have derived. So from x-axis, the centroid D4 lies at the distance of 4r by 3 pi. That is 4 into 650. R is 650 divided by 3 into pi. So all these y values are positive because we are measuring above x-axis. Now let us simplify this and check what is the value of sigma ai and what is the value of sigma ai yi. So here first I will multiply this for 200 into 1000. So this is 2 into 10 power 5. So 2 into 10 power 5 and this is also 2 into 10 power 5. And now this value will be pi into 650 square into pi is equal to divided by 2. So it will be 661.45. It's negative because the area is deducted. It's a cutout portion. Now if you add all these, you are going to get sigma ai. So a1 plus a2 plus a3, these three minus a4 gives the value of sigma ai in millimeter square. Now let us calculate that. So 2 into 10 power 5, it is 2 lakhs, plus 10 power 6, that is 10 lakhs, plus once again 2 lakhs, 2 into 10 power 5, then minus 6 minus 661.45, which is 736,338.55. 736,338.55. So this is the value of sigma ai or a, total area of that shaded region. Now we have to multiply these two and we have to write sigma ai yi here. So let me write that 2 into 10 power means 2 lakhs. 2 lakhs multiplied by 333.33, it is 6666. 6 totally you have 5 sixes followed by 3 zeros. That is the value. Then 10 power 6 into 500, which is 5 followed by 8 zeros. Followed by 8 zeros. Yeah. You should be very careful here because there are big numbers involved. So I will write here this as 5 followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. That means it is 50 lakhs, 50 crores. Then the third value is the same as the first value, 666 0 0 0. That is 2 lakh multiplied by 333.33. 5 sixes followed by 3 zeros. Yes. Next here of course this I have to calculate. This value is 4 into 650 by 3 pi. 4 into 650 is equal to divided by 3 is equal to divided by pi. The value is 275.87. 275.87. So now if you multiply those two, you get a negative sign because area is negative. So this multiplied by 661.45, which is 183,083. 183,083. 333.9. Yes, this is the value. Now, if you add all this, you will get sigma ai yi in millimeter. So let us calculate that. 5 sixes followed by 3 zeros plus 5 followed by 8 zeros plus 666 minus 1830 83333.9. So the value is 450,248. 450,248. 666.1. Yes, millimeter cube. Yeah. Now, if you use this formula, y bar you are going to get. So y bar is given by this formula. I substitute for sigma ai as 4502.4866.1 divided by sigma ai is 736338.55. So now the answer here is y bar you are going to get in millimeters. That is the distance of the centroid of the shaded region, culvert portion from the x-axis. You are going to get it as, so let me simplify this, 4502.48666.1 divided by 736338.55. 611.47. 611.47 millimeters. So centroid will be lying at a distance of 611. Of course, 611 means it is less than 650, it will be in this semicircular portion only. So now that is the location of the centroid. Using that, now we can find out the moment of inertia of this section about the centroidal axis. Now let me calculate that. So we have got x bar here as 611.47 mm. Now we will see how to calculate the moment of inertia of this shaded area about its centroidal axis. So for that, what we have to do here is we have to use parallel axis theorem. So for using parallel axis theorem, you need the distances of the centroid G of that shaded region from the three, that is individual centroids, that is G1, G2, G3, G4, and we have to use the parallel axis theorem. Now let us calculate the moment of inertia now. So I will use mi of section about horizontal centroidal axis, that is IDX. IDX we have to find out using parallel axis theorem. Parallel axis theorem is used. So according to that, you know parallel axis theorem. Now what I will do here is I will just write down the distances, only distances. Since he has asked about horizontal centroidal axis, distances will be vertical. Now let me take this as the x-axis. I need only distances. This is y-axis. Let me locate the centroids. All the centroids will be lying on the y-axis only. Here, no, of course, this G1 and G3, they will be at certain distance. But anyway, I need the distances. Let me mark like this. So G1 is at a distance of 333.33. So I will take G1 as well as G3. Both of them, they are at a distance of, I will write here, 333.33 millimeters. Then G2 will be at a distance of 500. So 500 will be, so here I will write, so G2 is at a distance of 500. G4 is at a distance of 275.87, and it will be here only. This is G4, is not to scale, please note, this is 275.87 mm, and G will be at a distance of 611.47. 611 means somewhere here, so 611, this is G, so G will be at a distance of 600, this is 611.47, this is your bar. Now for using parallel axis theorem, I need the vertical distances of G1, G2, G3, G4 from G. Then only I can use the parallel axis theorem. So let me now write the vertical distances between them. Then I will use the parallel axis theorem. So let us write down the vertical distances now. I will mark the vertical distances as from G to G1. From G to G1, I take this distance as YC1. From G to G2, I take the distance as YC2. From G to G3, this is same as YC1, this is YC3 because they are lying on the same line. From G to G4, I take it as YC4. So these are the distances. Now once I get, I have these distances, we can find out, we can use parallel axis theorem. So let me write one by one. YC1 and YC3 they are same. So YC1 will be equal to 611.47 minus this 333.3. So this is YC1 as well as YC3. So I will take this value as now 611.47 minus 333.33, which is 278.14. 278.14 mm. Next, coming to YC2, distance between vertical distance between G and G2, G is 611.47 minus 500. So that is 111.47 millimeter. So this is yc2. Then yc3 already is equal to yc1. yc4, distance between G and G4. So distance between G and G4 is 611.47 minus this polar value, that is 272.87. So 611.47 minus 275.87 will be equal to 335.6 mm. So these are the distances. Now I will use the parallel axis theorem. So if I draw an axis, x-axis, that is dx axis. So this is the centroidal axis. Now if I want idx will be equal to ig1x plus a1 into yc1 square. This is according to parallel axis theorem, plus ig2x plus a2 into yc2 square plus ig3x plus a3 into yc3 square plus this is minus because semicircle is a cutout portion, ig4x plus a4 yc4 square. So this is the expression using parallel axis theorem. Now you have to write down the formula now. First one is this one is a triangle, this one is a square, this one is a triangle, and last one is a semicircle. So we should write the formula to find the moment of inertia of these simple sections about their centroidal axis, and then we have to simplify. So ig1x is for the triangle portion. For the triangle portion, the moment of inertia about its centroidal axis is bh cube by 36. bh cube by 36, where b is the base is 400 here, into height is 1000, bh cube by 36 is the value, plus a1 is that area of the triangle, which is 2 into 10 power 5 into yc1 square. So yc1 square is 278.14 square. So this is for the triangle portion. ig1x plus a1 into yc1 square is this one. Then plus for the second one, it's a square. For the square about its centroidal axis, the formula is about centroidal axis is bd cube by 12. Here b is 1000, d is also 1000 for the square. 1 cube divided by 12 plus a2 is the area of the square, which is 10 power 6 into yc2 square. yc2 square is 111.47 square. Then plus the third one is also triangle of same dimension. So therefore 400 into 1000 cube divided by 36 about the centroidal axis plus 2 into 10 power 27 as that first one into 278.14 square. Then minus lastly you have for the semicircle, very important, that formula you have to remember the formula of moment of inertia of a semicircle about its centroidal axis. It is 0.006858, exact value 0.006858. Better you remember that, otherwise you have to derive 68598 d power 4. D power 4 is diameter. Please note that I am writing in terms of diameter. So radius is 650 for the semicircle. Diameter becomes 1300. So square of that to the power 4. Diameter to the power 4. So that is the expression of moment of inertia of semicircle about its centroidal axis. Then plus A4 is this area 661.45. So this minus I have taken here. I have taken outside. So area of a cutout portion is negative. Moment of inertia of a cutout portion is also negative. Into I have to take y to the power yc4 to the power yc4 square. yc4 square is 335.6 square. 335.6 square. So there are 4 terms here. If you are very careful, first one is for first rectangle, first triangle, second one is for square, third one is for third triangle, fourth one is for semicircle. It is negative because it is a cutout portion. Now you very carefully you simplify these values, you are going to get the final answer. Please check the answer. I give the answer. IGX is equal to 4.0788 into 10 power 9. So the final answer I am going to give for this. So IGX is equal to 4.0788. Please check the answer carefully. So that is the final answer. So if you be very careful when the values are very high, in millimeters means it will be very high. If they are given centimeters or meters, the values are going to get lesser. So IGX, after simplifying these 4 expressions, 4.0788 into 10 power 9. Please check the answer. So this is the answer. So this is how you have to do the problem. So initially we have to split the composite section into simple sections. In this problem there are 2 triangles, 1 square and 1 semicircle. Semicircle area is negative because it is a cutout portion. You have to locate the centroid because you have asked the moment of inertia about the centroidal axis. Then you have to use the parallax theorem to find the value.